Welcome to our classroom. Welcome to the classroom. Welcome to the classroom. A block like that, it's going to do a lot of damage to your car. You don't want that falling on the road. So we've got to design our slope so that the rocks don't fall on the road. And that's why recently they widened the shoulder of the road so the rocks fall on the side of the road, not in the road itself. So let's go have a closer look, take some measurements, get right into it. All right, so I've got this app called Clino on my phone. Click that. You can see we've got a compass on there and our little strike and dip measurement. So we can go lay this on our fracture plane, on our foliation plane, our bedding plane, whatever it may be, and just hit that little Clino, the little indicator, take a measurement, and then you can see we can record some things. I've already got marble written on there. So let's go take a bunch of measurements. The nice thing about the app, the Clino app on your phone, is you don't need to remember the right-hand rule. It does it for you. But you always need to remember the right-hand rule when you're actually looking at the data to understand which way is the right strike and dip. So don't forget the right-hand rule. So up close and personal, how do we know this is a metamorphic rock? Well, we can see some features like these dark blebs here. They get cut out and they're kind of deformed and stretched, and they're parallel to other layering that we can sort of see here. We can see this ledge. That's kind of a layer that repeats itself throughout the outcrop. It forms a fairly continuous, I mean it's stepped and so on, might be a little bit wavy, but it's a continuous plane along the outcrop. We can see, and it might be hard in the video to see other sort of features that align with this plane that we see right here. We also see here vertical fractures. We've got fractures going vertically this way. These ones might be induced when they excavated it with an excavator. These probably natural fractures that existed. You can see these are fresher surfaces. These ones have a lot of mud and so on. So all that soil is flowing down and it rains into all the fractures. This outcrop has a lot of moss. It's very difficult to identify where the foliation is, so we have to have a real close look. But here we've got a little bit of an exposure, and you see some planes along here and here. We're unsure if those are joints or are they foliation, but if we have a close look, we can actually see a similar plane coming through this section where the moss isn't so thick, and so that lines up with these other planes that we see, and we know that the foliation should be pervasive throughout because the whole outcrop has undergone heat and pressure to turn it from limestone to marble. So that foliation is going to be pervasive, and joints and fractures, they'll terminate here and there and won't be as continuous. So we can see this plane repeated at the small scale here and at the large scale there going across the whole outcrop. So I'm pretty sure that's the foliation plane. We've got to compare our measurements from this location and the measurements from the other side, and geology is like a puzzle. We've got to get all this data, collect it together, understand it, and it should make sense at the end of the day.